Okay, so we did that quick pass of Visual Studio, just kind of getting it installed and a couple quick things, but I wanted to do a quick example, sort of a quick example. It took me a minute to put it together, but I think I got something that covered all of the concepts we've seen so far in the class. So like list and selection structures, a couple different types of loops and variables and working with some strings, but kind of a quick pass at a whole bunch of the things we've seen so far in the course. At least one way to do it, like always in programming languages, there's more than one way to do it. And Visual Studio itself is it's huge. So we're just kind of getting a start here, but hopefully this will help you all get through the project over the last couple weeks of the course. And as far as naming conventions this week, we're going to just kind of use sort of a standard or sort of a mix of all of them. The one I usually follow is going to have Hungarian notation for what shows on the screen, just regular camel case for variables and methods, and Pascal case for object names. So that's kind of the convention that I think I wrote that up for the syntax, but Pascal case for objects, camel case for variables and methods, and Hungarian notation for anything that shows on the screen. So when we start Visual up, we're going to go create a new project. And when we scroll through here in the previous video, we kind of looked through it because it was just installed. You should have a recent template showing that if you opened the right one last time, will be over here. Something that says Windows Forms with Visual Basic. So if we go ahead and create one of those, I'm going to call this Gradebook Example, and need to store it somewhere. Whoops, I forgot to put the flash drive in. Okay, now I should have a flash drive. There we go. Let's see, this is going to be Module 7, Lecture 1. Then I'll create another folder called Module 7, Lecture 1 Example Files. And I'll store it there. The rest of that is okay, so go ahead and hit Create to get the project going. And you might notice when you open it, it keeps it in the same, it has the IDE set up in the same form you put it in last time. So let's do a quick pass at that. If we go to Windows, up here at the top, under Window, Reset Window Layout. Yes. So this is what you should be looking at when you first install it. Things over here kind of hidden over in the, we call these gutters, going down the sides. And these are extended, and we don't necessarily need to see all of them. Well, I'll start here. You should be seeing Solution Explorer, and you'll need to keep access to that somehow, because if something gets closed, this is where you'll open all the files for the IDE. So like if I close the form here, when I need to reopen it, I need to come to the Solution Explorer and double click on it here. And that's what opens it for this. So you'll want to keep the Solution Explorer open. So instead of just closing it, click the little pin to auto hide it, and that moves it over to the gutter. So then it's over in the gutter. We can do the same thing with properties to kind of open up space if you'd like. Usually the way I like to work, I'll have the form in the middle, and then I'll go ahead and hit the pin on the toolbox over here, to get to all the components, and pin the properties open because we'll need both of those. And let's see, before we start putting controls on here, let's kind of talk about this. We talked about it in the previous video. You want to make sure and give everything a name under design. So if you scroll down, there's different ways. We can put it in just alphabetical order, or this first button categorizes it. Whichever way, if you scroll down to, if it's categorized under design, where the one with name in parentheses, if it's in alphabetical order, it's right up near the top, the one with name in parentheses. That is the reference name we will use to refer to it in the code. So let's give that a name, and the overall form is the object we're creating. So following the naming convention, I'm going to give that a name in Pascal case. I'm going to call it gradebook form. And one thing that always bothers me, notice how I changed the name. So in all the code, I'm going to refer to this as gradebook form, but the file is still called usercontrol.bb. So if we come over to the Solution Explorer, if you right click on it here and go to rename, it will do all the refactoring for that. So I'm going to call that gradebook form and give it the same name as what I called it. That way, if there's a bunch of tabs open, I can tell what's what. I just always like to do that and just match the name. And then this is still set to auto hide, so I can just click anywhere else to get it out of the way. So you might want to hide those so that you can just come open them up as needed, or leave a couple. I usually leave the toolbox and properties open, but keep the rest of them, just hide them in the gutter instead of actually closing them so you can get back to them. And if you get confused on the window, if you get lost on the windows, because this is a really large IDE, just come to Window and reset and kind of start over. It's the easiest way to do that. And you want to play around a little to give the form different appearances, right? Like the border style, and just choose different, give it a 3D border or something, make it look a little different, change some colors, do some background images, and just kind of mess around with that. Just kind of setting up the IDE for the parts we'll need and getting started with the more useful names. But make sure you give everything that you might refer to in the code a name in the design section, or the one that says name in parentheses, because that's how we refer to it in the code. So let's add some components to this. So the quick plan here, this example that should at least cover one quick version of a lot of the syntax that we've seen. I came up with an example that covered everything in a sort of a gradebook piece of software. So basically we'll have a couple text boxes to input a student's name and their score on an item, then an add button, and then have a list box to show all the students' scores, and then probably another list box to show some averages, just like the class average and things. And that way it includes making a list or an array, and some functions that we can use, an if block to find the grade, and then we'll have a button to save to a file and open a file, which we kind of limited. They won't have everything. Like from the plan I have here, we're going to lose the statistics when we save it and reopen the file, but that should be an easy extension when you all are messing around with stuff. So I like to start by putting together the form. So let's kind of get that made. So the first thing we'll need is some text boxes to enter the student's name and their grade. So I'm going to come down here and find a text box. And I usually use the all well, I just go to all of them and sort out, but you might prefer the categorized ones to find things. I usually just keep the all list open and scroll back and forth in that myself. And we can either grab it and drag it over or just double click on it, and that'll throw it up on the screen somewhere. And just kind of drag it around until you figure out a position you want to put it in. And then we want to, like we said, we want to give it a name, because this is how we refer to it in the code. So the reference name. And it shows on the screen, so I'm going to use Hungarian notation, which is a short 2 to 4 letter prefix saying what it is. So I'll use txt for text box. So txt name. And that way we can refer to this text box, get the value that's in it, or put values in it after we do some processing. And we definitely want the users to be able to know what goes in that text box. So that's what labels are for. We come up here and find label. We just drag that over and notice that little boxes, little guidelines will show up when it seems like it's in a good place. And that'll just say what goes in that text box. So it's just a label, so we're not going to need to refer to a label from the code. So I'm going to skip over that. I know I said it's going to label everything in the form, but we're never going to need to refer to the label. The label just tells the user what goes in the text box. So all I'm going to do is change the text. So if I come up to appearance and change the text that goes in, that shows in that label. So this is going to say name. That way the user knows what goes in that box. And then you can do some other formatting. A lot of that should look familiar from other things you've used. Change the font. And just go in here and pick some different font to put on there. Oh, it looks like I have a Harry Potter font. That'll be good for a grade book. And some sort of name, and then the text box that goes into it. And maybe not change it. I'll go back to the original one, but change the colors of it and all of the different things like that. It should be fairly obvious. So that'll give us our user a place to enter a student's name. And I want it to look almost the same on the other one, so changing fonts and colors and alignment and all of that. If you do that, you probably want other labels to look the same, so at that point, it might be better to copy and paste them. So I'm going to just drag a box around it, just like both of them, then Control-C and Control-V to paste, and then just drag that to where it's kind of aligned with it somewhere. And then once again, change some things. So this label will need to say score. And we want to refer to this box because we're definitely going to want to get the score whenever we're writing code so that we can figure out what the student's grade was. So again, in Hungarian notation, it shows on the screen. So Hungarian notation. Short prefix, I'm just going to use txt for text box. And this is the text box holding the score. It gives us a way to enter a name and a score. So like Bob made an 87. And then the processing on the backside will figure out what Bob's grade is. That Bob's 87 counts as a B. And we probably want to put that out somewhere. So a good output thing is going to be a list box. So I'll bring that over here, kind of line it up with these. I'll make it a little bigger. Something like that. And I'm going to call this Lst Report. Just kind of making up a name. This is after we enter names, like Bob and Sally and Steve and Becky and all of those names and figure out their grades, just have a little report showing them. And list box is really nice for that. Those are the ones we can select items from and do stuff. We won't be doing that today. We'll just kind of use it as a nice organized output. But we probably want a label on it to show what it is. So I'll bring another label in, kind of line that up with everything. And again, I'm not going to refer to the label from the code, so I don't necessarily need a reference name on it. But the text property of the label should definitely be changed. I'll just change that to say report. And then in order to show all the stuff we've seen, in particular, which one did I use for this? The for loops. I used a for loop to a list to keep all the scores and then loop through that to find the average. So I'm going to select those again and copy, then paste, and make an output for the average or other statistics. If you want to mess around and kind of expand it a little, you could probably come up with some other statistics that are useful very quickly. I spelled that wrong. Statistics. And then I'm going to call it list box. Down here, select list box and give it a reference name so we can refer to it in the code and output things to it. So LST statistics. LST for list box, just the Hungarian notation with a short prefix indicating what it is. And that gives us the places for inputs and outputs. Well, we'll need a button so that whenever we add a name and a score, we'll figure out what their grade is and put it on the report, update the class average. So come up here to button, drag that over. I'll just kind of look for those guidelines to line everything up. And this will be button add to add the latest student score to the thing. And the text for that, I just say add. That'll work. And I'll go ahead and finish out the plan for the form, because we've also seen how to save data, right? Write a text file. So we'll write some stuff to a simple text file. We'll take whatever's in this box and write that to a text file, and then have an open button to grab what's in the text file and throw it back to this box. So obviously we'll lose the statistics when we do that, but just kind of going over syntax here. So I'm dragging some buttons for that. So just look for the guidelines, kind of position it. And this one will be a save button. So I'm going to change the text over here to say save. And you might want to mess around with some of the appearance, make it, customize it a little bit, make it look the way you want it to look. And definitely going to refer to that in the code. So I'm going to call that btn for button and save. Did I rename the add button? I don't remember. Yeah, I did. So one more button for opening as well. So just kind of line things up. Should be some grid lines show up or guidelines show up to help you get it in place. And I'll call this one btn open. And I'll set the text property on it to say open. That's kind of our little form there. And I always like to, once the form's made or at some early point, go ahead and run it and make sure everything looks right. So if we hit start, as of Visual Studio 2019, it runs in a little sandbox when we set it to debug. When you want the actual version, just switch the build to the release build, and that'll build the actual version, the actual executable file. But for debugging, we have this nice little sandbox that protects the rest of our computer. And we can type some stuff in here, type some stuff in here, that works. Buttons click, but they don't do anything yet. And there's nothing in the report, but the list boxes are nice. Those are the ones you can double click items on you can click the items in a list box to select them. So those are kind of useful. So that's kind of what our report looks like. Our little form is going to look like. Places to enter the names and scores, and then we'll make a report for the output, and then throw up some statistics about the class grades. We can close the sandbox there. Oh, and it closed quickly. Let me run that again to point at another button. If for some reason something goes wrong in the sandbox, and like maybe you accidentally set up an infinite loop and the program stops responding, over here what you can always do is come back to Visual Studio over here, and you see the big square red button that'll stop that. So if something gets stuck, you can just come back to Visual Studio and hit the stop button. All right, so that puts our form together. Let me get this output out of the way. And now we can start writing some code for that. So when I go to start making the code, I like to go ahead and get things set up and then fill it in. So here in our GUI, there are 3 buttons. So I'm going to go ahead and double click them in the order I want them to show in the code. So I'm going to double click the add button, and that'll get things started because I want that one first. And I'm going to add some white space in here. You can come back and add some other stuff in there. I always like just my style. I put the buttons at the bottom, all the button click sub modules at the bottom, and then my own sub modules and functions at the top. But either way would work fine. But I want to put the add button first, then the save, and then the open. So before writing any code, I'm just going to double click on all of those in the order I want them to show up and add a little bit of white space to hopefully make it easier to read for the example on the screen. And double click the open button. And that way those are there ready to go whenever I get down to writing the code and in the order I want them to be in. So that's going to create our gradebook form object. That's this GUI basically. And those will be have the listeners and handlers for the click events on each button. So one thing about picking a gradebook example is hopefully everybody's kind of familiar with how that works from your classes, seeing gradebooks and stuff and things we need. So to start with, most things are going to have local scope like we've seen with our examples in Python. But if we want global scope on something for our object, just put it at the very top outside of any functions. If it's at the top outside any of our functions, then we can use it inside any of the functions. So picking something for global scope, whoops, I meant to do camel case there. I'm going to create a list called class scores. And there's lots of types of lists we can use. A good basic one that's fairly efficient and easy to work with is going to be an array list. So I'm going to declare and instantiate that right off the bat. So we can do those in one line. So declare or dimension an array list, and then go ahead and assign it to just a new empty array list. And then we have some methods, .add to put stuff in it, .remove, .clear. There's a few different things we can use. But to work list, which we have seen into the example, I decided to just add all the scores to a list, and then we'll use that to find the average and also cover global variables. So just put it outside of any functions. And let's see, so our main thing is going to be that add button. So if we go to the code for the add button, that's where most of everything's going to be, that's basically where we're going to start. And we'll need a couple variables. So obviously we'll need a place to hold the name and the score that comes in. So start with that. So dim name as a string and dim score as double. So that is a double precision floating number. I think it's 64. If we just said float, that's a 32-bit floating point number, and a double is 64-bit floating point number. And a couple decades ago, those extra bits made a difference. They don't make much of a difference anymore, so you might as well go with the more accurate double accuracy floating point numbers. And once we get the score, we'll use that to find a grade. So we'll set up a variable to hold that in. Grade is a string, A, B, C, and so on. And we'll come back and do the average stuff. So let's go ahead and just do a little piece at a time. So that'll grab the name and the score, and then we'll find the grade. So I'll bring those in. So name, we're going to assign that whatever's in that text box. So we put that box on the form called text name, and we want to grab the text attribute out of it. So whatever the user types in there and then clicks the button, we're going to put that in this variable called name. Same thing with score, almost. I'll go ahead and type it up from the inside out. So once again, whatever the user types in that text box, we're going to grab that and put it into the score thing. But like we saw many, many times with the input on Python, what the user types in a text box is going to be text, i.e. the user types in a string, but we want this score to be a number, a double precision floating point number. So there's a number of ways to cast it. What I think's easiest is there's this abbreviated method, C double. If I push the N key, get the cursor over there, then close the parentheses. We have this method C double for convert to double. And there's that abbreviated one, convert int, convert string, C int. Makes the conversions nice and easy, and it's a lot like what we've been doing in Python. A lot of examples want to use the longer one where we actually write out convert dot a whole object-oriented, big long object-oriented thing, but C double, C float, C int, C string, those are a lot closer to what we've been doing in Python. And that's what I wanted to do in this example, is basically cover everything we've seen in Python so that you can duplicate some of what you've seen. Some of the little programs you've made, you can duplicate here for practice once you've seen the syntax for how to do it in Visual Basic. And then our grade, well, we need to figure out what the grade is, right? Like if they get above a 90, that's an A. Between 80 and 90, that's a B. So that's going to be an if statement. But also wanted to go over functions. That's one of the things we've seen, functions and methods. And in this case, we need to return something. So we have two types of keywords for setting up functions. You can see here on our button click, we had a sub. A sub function does not return anything. Sub is like a void. So it's a void. If you're just going to do stuff and then be done with it, that's a sub. If you want to return stuff, it needs to either be a private or a public, and then function. So subs are voids, functions are returns. And then give it some sort of name, so like find grade. And we talked about this when we were talking about methods. It was in the lecture. We can either pass our things by reference or by value. If we pass it by reference, that means it's referring to the same spot in memory. So if we pass in score by reference, and then make changes in this function, that will change the value of score when we get back to the calling, to where it was called from. We could also pass by value. And if we pass by value, that only kind of makes a copy of what's in score and sends that in to work with. So if we change it inside this other method, when we go back to wherever it was called from, score would still have the same value it had beforehand. So you want to be careful. Unlike Python, we can pass it both ways, so we have to say how we're passing it. So we're going to pass by value this thing called points. Score would probably be a better name, but I want to change it up a little just to indicate it's different. And then Visual Studio finished it. That function ends with the words end function. So in this case, we just need an if block to determine what that grade is, and then we can return it. And our if blocks look something like this. So the keyword if, then the thing we want to check, points greater than 90, then. So it's like if then. So if this is true, then we're going to do this stuff, and the if block will continue down until we hit the words end if. So if the points are greater than 90, we want to return an A. Then we have a bunch of these to check, right? So our next one is else if, and it's wrote as one word. So else if points greater than 80. So if it's not greater than 90, we'll check and see if it's bigger than 80. If it is, then return a B. And this next one, I'm just going to type and let the IntelliSense correct it afterwards. Notice how it undid that ending. So here where I'm at, I'm just going to type else if. If you forget and actually put it in 2 words, it'll correct it in a moment. Like else if points are greater than 70, then return a C. Notice how it corrected a bunch of those, like send the case and things like that when I did that. I think on this next one, else if points greater than 60, I think I can skip typing then. Oh no, I do have to type then. I was thinking it might do that. Oh, I forgot else if. That's probably why. Else if points greater than 60. Yeah, I just hit enter and it corrected that to else if, switched the indenting to line everything up, and threw in the keyword then. So the IntelliSense is really useful. You'll want to try to kind of get used to how the computer does that, because when the computer does the typing, well, it never makes a typo. So if, condition, then whatever we want to happen in that block, which is identified by the indenting. Else if is combined in one word, again condition, then, and eventually we'll get down to just else, which is the default, so we don't need anything else. The else doesn't need a condition or even the word then, because if nothing else runs, then do this. Return F. So that's the syntax for when we want a method to return something. Our keyword will be function if it's going to return, a sub if it's not going to return anything. So a sub for void functions and function for return functions. The syntax for an if block. And when you pass parameters, when you set up parameters, you have to explicitly state whether you want it passed by value or by reference. Then we can come down here and call that. So we set up that string called grade. So grade is going to be assigned find grade, that function we just made. And as soon as it shows up on the IntelliSense, you can double click or hit tab And find grade expects something. So we need something passed in. So we're going to pass in scores. Whoops. Not that. Score. So that will take the name and the score from the box, use that score to find the grade. And now we're ready to throw that up on the screen. We'll come back in just a moment and do the stuff with the averages. So obviously, we'd want to add the score to that list so we can find averages. But just taking it a little piece at a time, and a point I've made before is I like to write the code in the order that I think about it. And it just has to be in a certain order for the computer at the end. But usually the order the computer needs it in is not the order I think about it. So I do a lot of back and forth. So I want to accentuate that point again, and we'll come back and do the class scores because that would probably be done right here at this point. And we're ready to throw this on the screen. So we have that list box. So now that we've got the student's name and used their score to find a grade, we can throw it up on this list box and just get a report of the students and the grades from the class. So we want to refer to that box, so I called it Lst Report. And notice once I started typing, the IntelliSense kind of expects me to use my variables first. So you don't have to type very far, and you can do some planning with that. Like if you have lots of variables, have them all start with different letters, and then you can usually get to them from the very first letter. But the Lst Report, and then that's an object, so we need to refer to some things about that object. It's a list box, so a list box has items, which the IntelliSense predicted right off the bat. So we want to refer to the items in there, and we're going to add a new one. Well, IntelliSense almost got that right. It was the second one on the IntelliSense, and we're going to add some string here. And the string we already have. So we're going to put the student's name, and concatenation in strings is an ampersand. So the symbol above the 7. And then the grade, we want to space that out a little. So we have this built-in variable we can ask for called VB tab, which is just, should be kind of obvious, adds a tab in there instead of just a space. And grade. So we're going to put the student's name in the list box, add a tab space, and as you mess around with different things, with some of your stuff, you might need a couple tabs or different spaces. You kind of figure out the spacing. Ampersand to concatenate the string together, and then we're going to throw up the grade one. So let's run that and see if that works. And remember, you want to hit save all. If you hit save, which is Control S the normal way, that only saves the one you're looking at. So make sure you hit save all, because we have lots and lots of files going on in the solution. The solution is the Visual Studio project, all the files together. So after you hit save all, you can come over here and hit start to run that in the sandbox. So I'll go ahead and maximize this. Should be able to enter a name. So there's a student called Bob, got an 87. We'll add that. Oh, yep, Bob got a B. Let's try another one. Well, first thing I'm noticing is it'd probably be convenient if we cleared that text out automatically and moved the focus back to that text box ready to type the next score. Maybe a student called Sally got a 91. Add that score. Oh, so it seems to be adding to the list box, and here you can see that these are, with the list box, you can select ones off of it and then right click write code related to the selected ones. But first thing I'm noticing is probably want to clear these boxes out automatically and get it ready to enter the next grade in there. So go ahead and close this and stop the run. And I'll come down a few spaces and make sure that's the very last thing that gets done in this little sub function. And clearing a text box is really easy. All we do is put an empty string there. So the text name text box, we're going to set the text attribute equal to a blank string, the empty string. Same thing for score, text score.text is going to be assigned the empty string. And that'll clear out what's in the box. And to move focus back to that first text box, text name, we can do .select. And we're just going to move the focus back to that text box, is what that will do. So let's hit save all and run that, see if it works. Just remember, you always want to test your code every chance you get. Because if you can test it after just 2 or 3 lines and an error crept in, well, you know that error had to have come from those 2 or 3 lines, so it's just typed. So let's see, some student scored a 76, hit add, put it on the list. We already checked that part, but you can see the cursor is back up here, ready to add another one, 56. Add. Okay, so that clears it out and brings the cursor back up there. It's just a useful little thing. Make it a little easier for the users. So stop that run. So the next thing, now that we've got the overall report of the grades coming, maybe some statistics about how the class did. You know, the average grade, and you could probably think of other statistics that would be useful there. But some statistics to put in there. We'll just put an average to kind of cover the syntax now. And notice how some of these lines look like they're about to run off. We might have to do that. We can go ahead and get these out of the way. If you come to that pen and click auto hide, it'll move those back over to the gutter without actually closing them, so we can still get to them if we need them. And we have a lot more room to see the code. So I'm going to write another function to find the average. Well, in order to take an average, we need to consider all the scores. So that's why I added that up here. So I'm going to come down here, and whenever we get the score from the text box, first thing I'm going to do is add it to that array list. So class scores dot add. And you can see here on the IntelliSense some of the different methods. You can kind of scroll through there. You can add, count, clear, index, a bunch of methods to work with. But for us, we're just going to add something, and we're going to add score to that. So whenever we grab the score, we'll use it. We'll add it to the list of all the scores in the class, then use it to find the grade. And then we can set up, find the class average. To do that, probably want a variable to put it, so I'll go ahead and dimension a variable here, class average as a double precision floating point number. And everything, we usually switch that to the grade, so I'll do a grade as well. Declare an average grade. Whoops. Average grade as a string. So we'll find the average of the numbers and then put some letter about the letter value on that, like we normally have. So to find that class average, I'm going to write a function that does that. just to go over that syntax again. We're going to return something. So once again, either a private or public function, depending on how you want it accessible. I'm making everything private because only the button, which is part of this object, is the only thing that's going to call it. If you wanted something from outside this object to call it, then you'd want to make sure and make it public, kind of like the class here. Other things can ask for the gradebook form because it's public, but only things in the gradebook form can ask for our functions here because we're setting those up as private. And I'll just call this find average. And we don't need any parameters to find the average because we have that array list. And I wanted to use this to go over the syntax for a for loop. We're going to get the sum of all of them, so we need to obviously a variable to hold that in. Sum is double, and I'll go ahead and assign it 0 to start it. So declare and instantiate it in one line. And then the syntax for our for loop. Well, there's different for loops, but for the ones like we saw in Python, we'll use the words for each, then some sort of reference value. I'll just say S. Well, I'll go ahead and write out for score in class scores. And notice it ends with the word next. All of our for loops end with next. I'm just doing the one that's kind of like what we saw in Python. So for each basically number in that array list, which has global scope, remember, just declare it outside of any functions if you want it to have global scope. I went ahead and you do have to instantiate an array list at some point. So I just went ahead and did that right at the beginning. Then for each thing in there, the sum is going to increment by that next score value. And it'll look for the local score first. The score down here is local to this function. So we can only find the one local to this for loop. So we're going to increment the sum by the score. That should look almost identical to what we do in Python. I guess the only difference is the word each shows up, and then we have another keyword to end it. And after we get the sum, well, we just divide that by how many we have. So to get an average is going to be sum divided by how many things are in that array list. So class scores.count will tell us how many things are in there. So we'll add them all up and divide by how many we have, and that'll give us the average. So I want to do that before I reset things. So I'll come back down here to find that. Back in sort of our main processing is on that add button. I'm going to take class average will be assigned find average. We don't have to pass anything in. Average grade is going to be well, if we want that as a letter, we can just call that method we already wrote and pass in that other parameter. Pass in that other value as the parameter, and it'll find whatever grade goes with that average score for the class. And then we can put it up on the screen. List statistics, .items, and every time we enter a new score, we don't want a whole bunch of statistics showing. We just want to see one. So I want to put this in here somewhere. It seems like a good place for that. We can call this clear method that's built in. So we're going to clear out the list and then add something else to it. LST statistics .items .add the average grade is ampersand for concatenation, then average grade. and that'll find the average grade and put it in that other list box. Let's hit save all and check that, because once again I was talking and typing at the same time, so it's kind of like I'm begging for typos to happen. But just remember, save all, not just the file you're looking at. And that runs. Oh, I just noticed something down here in the corner I meant to talk about earlier. We'll look at that in a second. So we can put some scores in here. So let's say Bob got an 87. The tab's a little bit out of order. I'd like it to go to that add button before it goes to the report one. So we'll go back and change that. It's the next thing on the list of stuff to change. So we add that, throws the score up, gave the average. So what's another one? Sally got a 67. Click add. Those are grade up. Class average dropped from that. But it seems to be working. One thing I noticed is it'd be nice if the tab key worked, right? If we entered a name, then a score, and then the next tab took us right to that add key. So let's change that. That's going to be the tab stop behavior. So go ahead and close this. Get this output out of the way. And I'll come back over to the window, the form. And I noticed down here in the corner, I forgot to mention that we had talked about GitHub last week, and you'll notice there's this thing, add to source control. We can add Git right into Visual Studio. A little beyond the scope of this class, but then you don't have to clone your repository. You can just refer right to GitHub, and as long as you're connected to the internet, you'll be able to refer to any code on GitHub from your code in Visual Studio. You can probably Google a quick Google search will find you some examples of that. It's a little beyond the scope of this class, but we've talked about GitHub, so that might be worth seeing. So the order the tab key goes through these in seems to be a little off from what I'd like. So I'm going to open the properties back up, and I'm going to start here on the text field. Whoops. Open that back up and keep that open. There we go. And under behavior, there should be tab index. So we want this one to be first. That's where it's going to start, ready to enter a name. Then tab index 2 will, so it starts here, and then tab index 1 is actually this label which does not allow for tab stops, so it's going to skip over that one. Tab stop 2, then 3 is the label, so 2. And I'd like to go to this before it goes to this. So I'm going to take the one that's on that label because it doesn't even stop there. And what was the last thing? I think that was the last thing. So 10. And I'm going to change that label to 11. It doesn't even need to stop there. And I'm going to change the add button to number 3. That way, hopefully it'll go this box, add button. So we can hit type, tab, enter, and it'll run. So let's hit save all and check that. Just to make it a little easier for the users to use. There it is. This way we can keep our fingers on the keyboard. So name, I've been Bob, maybe Bob got an 87, hit tab, oh, that took us right to the add key, hit enter, it clears everything out, and then that reset and return the focus brought us right back to the name, ready to type another one. Becky, 65, yeah. So everything seems to be working, and that's just a convenience factor for the users. So keep the tab index order in mind, the order that the user, that way if they want to keep their fingers on the keyboard, they can go very quickly through the ones they need to go through. And that was under the button add. If it's categorized, it'll be under behavior for the tab index, and make sure tab stop is set to true. Otherwise the tab won't go there like the labels. Tab index, well, it doesn't even have a tab stop option, so tab stop won't go to the labels, but yeah, just make sure tab stop is set to true, and then set up the order that you want them to go through in. It makes it a whole lot easier for the users. Get that out of the way. Back over here. So that gets the values, data from the users, figures out what the grade is, puts that on the report, finds some statistics about how the class is doing, throws that up on that other list box. So a for loop here, selection structure, global scope for things. That's a lot of what we've covered this semester with Python. We'll also add in the save and open button. So kind of the persistent data. That's another thing we saw. So we're going to include that. And a while loop. We haven't seen that yet. So I'll do a while loop here in the save button, just to get it, just to show the syntax for that. We have a lot more types of loops in Visual Basic than we do in Python. So I'll do a couple. I'll do a while loop for saving it and a do while loop for opening it, just to go over a little bit more syntax. But to write files, well, we need to dimension a variable to handle, dimension a handler. And there's a number of ways to do it. Not quite the easiest way to do it. I started to do that and then was like, no, we've talked about object-oriented programming. I'm just going to show them a better way than the easiest way. So there are better ways than this. There are worse ways than this. This is not too complicated of one to start with. So we're going to call this system object. And that system object has an inner object called IO for in-out. And then that has a number of things. We want stream writer. So we're going to declare this handler as a system.io.streamWriter. So basically, those terms should kind of make sense. We're going to do in-out to this. We're going to create a writer with in-out just to the operating system for creating files and things like that. Then we need to assign that something. Go ahead and instantiate that. So that file reference just created, I'm going to instantiate that to my.computer.filesystem.open text file writer. Seems like quite a bit, I know. So, my.computer.filesystem.open text file writer. And everything's spelled out, so hopefully if you stare at that for a moment, the names of all those different parts should make sense what it's doing. It's much more explicit than what we saw opening a file handler in Python. And then we need to tell it where it's going to open the file to and how it's going to open it. So I'm going to come over here to the File Explorer and just copy the path basically. So I'm going to store it here on the example files here on the flash drive. So I'm going to copy that file path, get that out of the way, and then the file path is going to be a string. So paste that in, and then I'm going to add grades.txt. And then I'm going to throw in the word true here for appending. So we're just going to add to that file. We're not going to clear it out. True is appending. That means it adds on to the end. So if you put false here, then it's not going to add on to the end. It'll overwrite what's there. So now that we have a file handler, we can kind of loop through everything that we put into our list box and write that to the file. I could change that to false. I'll just leave it at true. And if this argument is true, then that means append. So it's going to keep what's already in the file and add more stuff at the end, or create the file if it doesn't exist. If you put that to false, it'll erase what's in the file and put new stuff there. So we're going to walk through this in a while loop, which means we'll need to set up a counter manually. I should do the whole formal thing as integer. As an integer equal to 0. We'll just do a basic counter. Then our while loop is actually going to look very similar to what we did in Python. While that counter we created is less than, and well, we're going to go through this list box. So while we're writing the code right now, we don't know how many things are going to be in there at a particular time, but the computer will be able to count that. So if we go to Lst Report .items.count. So while our counter is less than the number of items in the list box, well, each time through we want to ask that handler to write line. And then what is it going to write? Well, it's going to write that list box. We'll look at the items in the list box, and then we'll grab a particular item at the index we're currently at, and then convert that to a string to be text. And then before I forget, go ahead and increment the counter by 1. That way we don't accidentally enter an infinite loop. But until we get to the end of all the way through the items in the list box, we're going to just write each one to the line one at a time. Whichever one we're looking at, indexed by our counter, we're going to convert it to a string and add it to the file. And that's part of the reason I chose this is the syntax. It's written a little bit different, but this should be the one that's most like what we've seen in Python. And that's kind of what I was going for in this example, is just enough syntax that you should be able to duplicate everything we've done in Python this semester. So for practice here, oh yeah, and then this last part, remember to close the file when you're done with it. Always have to close the file when we're done with it, when we're done doing stuff with it. But hopefully we're seeing enough syntax here that we can basically duplicate every program we've wrote this semester. Just in list, some selection structures, the for loops, notation for function, setting up variables. Not a whole lot of calculations going on here. The math part should be trivial. We have the same operations: add, subtract, multiply, divide, modulus, an assignment. So that part should be hopefully trivial. If you have questions about it, let me know. I can add something in with kind of go over that. But this should be enough syntax to duplicate everything we've seen in Python. So any of the things you've done so far this semester, you can hopefully put together a GUI and rewrite your code for Visual Basic to run on a GUI just to get some practice. So I'm save all and test that writing to the file. And if it writes to that file, okay, which this I'm just referring to my flash drive, so yours is obviously going to look a little bit different from the file path, but just copy and paste it. It's the easiest way to do that. So let's add some stuff here. So let's say Bob got an 87, add that. Sally got a 91, add that. David got a 67, add that. Becky got a 72, add that. Sam got a 43, add that. So that gives us a bunch of things. And we've tested all the pieces, so we know all of those work. But the new one is we want to take this and add that to a text file. So if I come over here, I believe I wrote it into this examples file here. So there's no file here, so it should create that and then fill it up with stuff. So if you hit save, come over, oh, there, it created the file, and we can see it filled it up with that information that's in the list box. So I'll go ahead and close this. Get this out of the way. And then the last thing we need to do is read that back in. So obviously not saving our averages here. That whole statistics box is going to be thrown off from this, but just going over the syntax. And the syntax for reading a file is going to be very similar. Once again, we'll need a handler. So something, I'm going to call it file as a system .io .stream reader this time though. Obviously, to write it, we want a stream writer, and to read it, we want a stream reader. And then once again, we'll instantiate that. So file is going to be assigned my.computer.filesystem.open text file reader. And we want to read the same file, so I'm just going to copy it from up here. Control copy, Control V to paste it. And we only need one argument here because, well, when we're writing it, we could either overwrite stuff or add on to the end. But when we're reading it, well, we just need to know what to read. So only one argument passing in here. And a type of loop we didn't have in Python, I'll go ahead and throw another one in here, is we have a do-while loop, which is sort of a post test. So we're just going to keep doing things until it's done with it, until we hit the end of the file. And to find the end of a file in Visual Basic, there's this nice little thing we can use. So we can ask that handler. Remember, a handler is the thing that can see our file. So built into that handler is this method, this thing called peek, which basically just means look ahead. So we're going to just keep looping. So we're just going to do while peeking ahead at the next line does not equal -1. And then the keyword to end the do while loop is going to be loop. So do while this, and then keep looping. And this is how we write not equal to. So that's different than what we saw in Python. So less than, greater than, together, that means not equal. The exclamation point is used for other things in Visual Basic. So whenever there's no line on the file, the peek method will return -1. So we're going to look at the next file. If there's next line, if there's something there, it's going to return a number. And it'll keep doing that until it hits the last line, and when it hits the last line, then it's going to return -1. So while file.peak does not equal -1, well, I'm just going to throw it back on that list box. List.report.items.add file.readline. Some of that should look kind of familiar from reading and writing files in Python. It's very similar. The main difference is we're more explicit about what type of handler we have. But the general logic should make sense, and we have some other nice little methods built in, like look ahead at the next line to see if it's non-existent. But well, let's hit save all and test that. And that was a very quick pass, but that basically covered some version or another of everything we've seen this semester. So hopefully now you can take any of your programs from this semester that were written in Python and translate them over to this Visual Basic syntax and try it and get some practice with this. So if we hit open, oh, yep, there's what we wrote to the file. Then we can add more stuff to the file. So maybe another student, Zach, got a 92. Add that. So add to the file, save. Uh-oh. Notice this error says it's being used by another file, or it's being used by another process. Down here, I forgot to close the file. So since it's still open, we can't access it from the other one. Which is just back to that general point of always remember to close your files. Now let's try that again. So save and run. Oh yeah. Open that file, and now let's see if we can add something to it. So Zach got a 92. Add that. Put it on there. If we hit save, should have wrote it to the file. And if we open it, you can see all that stuff was just added on to the end. So that's kind of a quick pass at the syntax here. I'll add in some comments and send this file out. There's kind of like normal, adding comments, going over what I was saying while writing this. And it should be enough syntax to duplicate any of your programs, because we saw variables. Basic math should be trivial. If you have questions, let me ask. Or if you have questions, let me know. And we saw a selection structure, a for loop, different methods. The putting stuff on a list, throwing it on the GUI is a little bit different than what we saw in Python, but hopefully all that made sense. Resetting the form, remember, try to set your thing up, make it easy as possible for the users. That's the sort of stuff that's only going to come with practice though. And then writing files. Persistent data, that's pretty much everything we've seen this semester, so you should know the concepts of how to do that stuff. Here's the syntax for Visual Basic, so for practice, you should be able to duplicate any of these things. Oh, and when I add comments, I'll send out this whole Visual Studio project, but I'll make a copy of this particular one, the one with the code, and put that up on the top level of the examples. Make it easy to find. That way you don't have to open the whole project and reset the framework and that sort of stuff. But I'll send this out. Hopefully will get you started getting into practice with Visual Studio and Visual Basic and get you ready to work on that final project. And if you have any questions, let me know.